The effects of normal solar activity are very rarely felt, as we are protected by the Earth's own magnetic field, the magnetosphere. But this has a limit.
During one of these strong magnetic storms, that hammer-like blast strips part of the Earth's magnetic field back, compresses it, leaving us very little remaining shield.
The week-long bombardment due to the solar maximum has left our protective shield highly vulnerable. It is now that a sunspot, bigger than Jupiter, erupts on the sun's surface, unleashing a billion-ton electrified gas cloud called a coronal mass ejection, or CME. It can take anywhere between 12 hours and several days before we feel its impact on Earth. On hand to capture its deadly birth is a sensitive instrument called a coronagraph on board the SOHO satellite.
The SOHO satellite has telescopes monitoring the outer atmosphere of the sun. SOHO sees CMEs lifting off from the surface of the sun, headed towards the Earth.
But there's a problem. There is no way of knowing how fast the CME is traveling.
We can't track them between the sun and the Earth. We're only guessing. We're only hoping that it won't be as bad as it could be.
This ultimate solar storm doesn't hit in one go. It comes in stages. The first part of the storm, the solar flare, which is way ahead of the CME, takes just 8 minutes to get here. Commercial airliners are now in danger as X-rays within the flare can wipe out a plane's radio communications. Following quickly afterwards, just 8 minutes behind the solar flare, is stage 2. This is called the radiation storm, and this can start to cause more serious problems.
This is real radiation. These do radiation damage. They stream into the upper atmosphere. The electronics can be fried by these high-energy protons.
Despite the size of the storm, there is no way of knowing whether it will be damaging until they know its polarity. Just like a magnet, the storm has either a north or southward polarity. ACE can tell which way round it is. North, and it could bounce harmlessly off the magnetosphere and back out into space. But the other option is what everyone fears.
When you get a storm that has an extremely large southward magnetic field component and it's very fast, you know you're going to have a super big geomagnetic storm.
As the energy from the solar storm hits, it creates massive waves through the Earth's magnetic field that induce powerful currents to pulse through the electric grid system, burning out transformers. The biggest solar storm in history will cause the biggest and longest blackout.